Alright, y'all. In this video, we're going to go over the concept of contingency tables. So a contingency table, which is sometimes called a two-way table, what it does is it lists the values of two different variables. Okay, so for example here, consider the following contingency table, which compares the use of cell phones and speeding violations. So the way that you kind of read this is that in the horizontal direction, the rows will be whether or not the person used a cell phone or not. Okay. And then the rows represents whether or not they got a speeding violation. Or excuse me, the columns represent whether or not they got a speeding violation. So as you go horizontal, you're talking about whether they use a cell phone or not. And then as you go vertical, you're going over whether or not they received a violation or not. Okay. So I just want to make sure everybody can read this correctly. So as we look at this data set, the question is, how many people use cell phones in this data set? How many people use cell phones? So we're going to go to the row that has cell phone user. We're looking for the total number of cell phone users. It's going to be 170. So how many people use cell phones? 170. How many people received a speeding violation? So now we're looking at the column versus violation. We see that there's a total of 66 people that received a speeding violation. So 66 people received a violation in this table. So I just want to make sure people are able to go through and read this contingency table, basically. How many people did not use a cell phone and they got a speeding violation? So no cell phone and a speeding violation. So we're going to go to the no cell phone row and then the no speeding violation column. And there we go. 307 is the number of people that did not use a cell phone and received a speeding violation. And lastly, how many people were using this sample? Well, we have the total number right here. I'm circling it, the 493. So 493 people in total were surveyed. Okay, so I just wanted you guys to get a feel for how to read a contingency table. Okay. Now, from a contingency table, we're actually able to calculate fairly quickly some probabilities. Okay. So for example, we have the same contingency table, okay? We have cell phone usage versus speeding violation. All right, so the first question asks, what is the probability of selecting a driver that uses a cell phone and received a violation? So the probability of cell phone and a violation. Okay, so what I'm gonna do here is, as I told you in previous videos, go ahead and label up what your events are. So here, event A is that they have a cell phone. Event B is that they received a violation. So what they're really asking for here is, what's the probability of A and B? Okay. Well, we discussed some formulas in previous videos. Remember, this is the multiplication rule, but whenever you have a table and you have these whole numbers in them, you can actually just go ahead and avoid using the formula, because it's going to work out to be the same answer, believe it or not. So the probability of A and B will be the following. Okay. For A and B, this will maybe make more sense with the next example that we do. Just take my word for it now. There are no restrictions on your domain here. What I mean by that is we're trying to figure out what's the probability out of everybody that we select a cell phone user, a person that's a cell phone user, and they received a speeding ticket. Well, because it's out of everybody, our denominator is going to be that 493, that grand total of 493. Okay? But then what about the numerator? Now we need to locate the number of people that they have to have both of these now. It's A and B. Cell phone user and they got a violation. Cell phone user and they got a violation. That is the 50 that I'm highlighting now. So the probability that we select a cell phone user and a person that got a violation will be 50 out of 493. 50 out of 493. All right. Okay, I'm going to erase those. Next example here. What is the probability of selecting a driver? And I'll scroll back up to the table in just a second. But what is the probability of selecting a driver that did not receive a violation? What's the probability of selecting a driver that did not receive a violation? So once again, this is going to be out of everybody. What's our event here? Our event is no violation. I'm going to just call that A. So what's the probability of A? What's the probability out of everybody? Because there's no restriction. The only time you're going to have a restriction is whenever you have a conditional probability. And we don't have that right now. So out of everybody, just like before, the grand total was 493 people. I know the top was cut off there. And so, ouch, 493 is our denominator. And our numerator has to be the total number of people who did not receive a violation. And we see that this would be, come down, no violation, 427. So the probability of selecting a driver that did not receive a violation will be 427 out of 493. Okay. I think just a couple more here. All right, what is the probability of selecting a cell phone user given that the driver did not receive a violation? Super key word here is given. That means now we are dealing with a conditional probability. Okay. I'm going to let cell phone user be event A. I'm going to let no violation, did not receive a violation. We're going to let that be event B. So we are asked to calculate the probability of A, the probability that somebody is a cell phone user, given that they did not receive a speeding violation. So now what is happening, for the first time we see that now we are restricting our domain. What I mean by that is instead of selecting out of everybody, instead of our denominator being that 493, we are now saying that we're only looking out of a pool of people who did not receive a violation. In fact, if you go back to our notation, look at the probability of A given B. If you squint just a little bit, doesn't that kind of look like a fraction? Where the denominator of that fraction will be event B, the number of items in event B, number of outcomes. So if event B, that's why it's important to label your events, if event B is that we did not receive a violation, we know that 427 people did not receive a violation. That's why this is our new denominator number. It's not out of everybody, it's going to be out of just the 427. Out of just those 427 no violation people, we're asking ourselves how many of them used a cell phone? Well, 120 out of the non-violation, the non-speeding ticket drivers used a cell phone. So maybe ask yourself, why don't we use the 170? We don't use 170 because that includes both people that got speeding tickets and people that didn't receive speeding tickets. So that's what I mean by restricting your domain. We're restricting it to just people who do not receive a speeding ticket. So therefore, this conditional probability will be 120 out of 427. Okay. All right, last one for this table here, this contingency table. What is the probability of selecting a driver that did not receive a violation, given that the driver is a cell phone user? It seems very similar to the previous question, and I did that on purpose. And it's because I need to understand the importance on what you place your condition on. What's different about this one is that now the condition is that we already know that the person is a cell phone user. Okay? So what's the probability of selecting a driver that did not receive a violation? So we're going to say not receiving a violation. Once again, we'll let that be event A. And cell phone user, we're going to let that be event B. So we are trying to find a conditional probability here. We're trying to find the probability of A given B. Okay, in fact, I could have used the same events from the previous question, but then if I do that, then this flips, it becomes B given A. But anyways, what does this equal? Now our denominator, this time our denominator has to represent the total number of cell phone users this time. So how many total cell phone users do we have in our table here? We can see that there's 170 total cell phone users. So 170 is our denominator. And what's our numerator? So out of those 170 cell phone users, sorry about that, we're trying to figure out how many of them did not receive a violation. Well, 120 of them did not receive the violation out of just the cell phone users. Once again, you're restricting what you're looking at. So that's why this now becomes 120 out of 170. So as you can see, between the last two parts we did here, the last two questions, you can see that the numerator was the same, but the denominator was different because we are conditioning. We are restricting our domains there. Okay. And the last one, y'all, this is a pretty straightforward one. Based off the information that you know, can we find any missing values in a contingency table? Okay. So this is what you do. Come across here. So cell phone users, we know that there's a total of 145 cell phone users. 120 of them did not receive a violation. So that means that 145 minus 120, there's 25, there has to be 25 cell phone users that did receive a ticket, a violation. And it's just like a puzzle. You're just going to fill in the missing pieces, right? So now go down the column, violation. If there's 150 total people that got a violation, 25 of them use a cell phone. That means that 150 minus 25, aka 125 of them did not use a cell phone. And you just continue this pattern is all you do, okay? Coming across here, if I take 300 and subtract away 125, that's going to give me the number of people that did not use a cell phone and did not receive a violation. Next, to get the number of people who did not receive a violation, no speeding tickets, we're going to take 120 plus 175. That gives you a grand total of 295. I believe my math is correct. Then lastly, to get the grand total number of people in this survey, you can either take 150 plus 295, or you can take 145 plus 300. Either way, you should get 445. Alrighty, folks. Hope that helps you out with your homework. See you guys in the next video.